So this is where we left off yesterday. My job for you is to try and isolate the radical and solve it to the best of your ability. Because this is a step 2, or as of this point, it looks like a step 2 type equation. So I'm going to combine all of my like terms. Obviously, I can put the 2 and the 1 together. So it's going to end up making an x plus 2 times the square root of x plus 2 plus 3 equals 3 minus x. Then I really hope at this point it turns into a normal type algebraic equation where if you're trying to isolate this radical, you know to move everything else to the other side. So that means I'm going to subtract 3 from both sides, and I'm going to subtract x from both sides. So now this is going to turn into 2 times the square root of x plus 2 equals 3 minus 3 is 0. This one is the part where I think people are going to get stuck. If I didn't say this yesterday, I think people are going to get stuck because they're going to do negative x minus x is 0. And they're going to say the right side of this equals 0, which it does not. Negative x minus x is negative 2x. So now we have the equation that looks like that. Now, obviously, we have one more step until it's completely isolated, so we divide by 2. So we end up with the square root of x plus 2 equals negative x. So hopefully you're able to isolate the radical to that point, because that is just general algebra. That's not something that goes too far in depth with algebra 2 style thinking. It's just moving things over to the other side. So now we would square both sides of the equation. So this would end up with x plus 2 equals, now this is another important part, make sure you square everything inside the parentheses. Negative squared becomes positive, x squared becomes x squared, so I end up with x plus 2 equals x squared. So now I move everything to the side where the x squared is positive, so I'm going to subtract x, and I'm going to subtract 2, so I'm going to end with x squared minus x minus 2 equals 0. Or you could have 0 equals all that stuff, doesn't make a difference. Now it's a factor equation. So I'm going to factor into x minus 2 and x plus 1. So x equals 2 and x equals negative 1. Now, if you look at what you did for your steps, or if you look at where this problem started and where this problem ended, you can see that it was a pretty long problem, right? You can see that this was a problem that a lot of people would have had to use a lot of work on, which my initial thing to you was these problems aren't that difficult. They're extremely tedious. There's a lot of paper and a lot of work that you had room to make mistakes on, right? There's a lot of little calculations, a lot of little things that were happening that were easily, or that would be easily written down wrong or done wrong or anything like that, where you wouldn't have done it, the little stuff right. We now have to test these two things to make sure that they work. Yeah, sure.
So maybe I did the wrong problem. Was it plus 3 after the radical you had on this?
I changed it because it was x plus 2 and then x plus 1.
Yeah.
So I combined the 2 and the 1 to make 3.
There's a 2 on that?
Yeah.
I made a really confusing problem.
Yeah, that probably wasn't very easy then.
Well, I got 4x squared plus 7x plus 2, and I was going to start the quadratic formula.
You might actually be able to factor that one.
Factor that? No, plus 2. 4x squared plus 7. Well, yeah, you can multiply to 4 and stuff.
Yeah,
I forgot how to do that.
I think you can probably do that. All right, so what I'm going to do is go back to the original problem, and hopefully you still have the original problem written down. It was the square root of x plus 2 plus 1 equals the square root of 3 minus x. That's the original problem, and I am now testing the two values I just got, which were x equals 2 and x equals negative 1. So I'm just testing them to make sure that they work. Okay? So when I test those to make sure that they work, I am just plugging x in and solving to see what happens. So I'm going to plug 2 into here. So I'm going to get the square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. So the square root of 2 plus 2 is 4, or the square root of 4. So this is 2 plus 1 equals the square root of 1. So 3 equals 1. This one does not work. So that is not a true statement. So I'm going to do the same exact thing with negative 1. So now I have the square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. So I'm going to get the square root of 1 plus 1 equals the square root of 4. So we're gonna get 2 equals 2. This one's up. That was a good check mark. Very good check mark. Yes.
So how did you get a second one on the right side?
Think of what?
So where the
That x equals -1.
well, okay, so 3 minus 2, 1, and then where's the other one come from?
I don't know. This one right here.
Okay, so I mean, okay, my understanding is 4 squared is 2, 3 equals 1.
Yes.
Oh,
Which is not
wait,
true.
why did I start doing that?
I'm not sure. These are 2 separate problems.
Yeah, never mind.
You good?
Yeah.
All right, so now we're going to get into solving radical inequalities. I'm going to show you one example, have you work through one example, and then we'll probably be time for you guys to work on your big ideas. All right. So radical inequalities, very, very simple because they're like the step 1 thing that we did. So they're usually all like the step 1 style thing. So it's an easy style problem, but there's one more thing that you have to kind of remember. So let's say we've got the equation 3 times the square root of x minus 1 is less than or equal to 12. So we could solve this exactly like every one of you would probably think to solve it. And the way that you would think to solve it is to isolate the radical and then solve for x and be done, right? That is what you would think to do and you would be correct. That would be correct in what you're thinking. So I'm going to divide each side by 3, divide each side by 3 so that I end up with the square root of x minus 1 is less than or equal to 4. Now what would I do to solve here? I would square it. So I would end up with x minus 1 is less than or equal to 16. And then I would get x is less than or equal to 17. So now what I need you to think about here is I need you to think about what this answer is telling you. It is telling you that any number smaller than 17 will make this inequality true. Any number smaller than 17 will make this inequality true. Is that a true statement or not, and why? Yes, Andrew.
That might not be true because things that'll make the radical less than, well, I would say 0, right?
You're right.
Well, less than 0 would make the answer negative, so you can't do that.
So Tanner is saying that if the radical is negative, we can't take the radical of a negative number, right? Or the square root of a negative number. So if I have a negative number inside the radical, this thing becomes undefined and doesn't work. There's no solution anymore, which means that this is no longer a true solution. So what you have to think is you have to have your radical has to be greater than or equal to 0. Okay? Your radical has to be greater than or equal to 0. Which means that you have to then find out which values are bigger, or which values will work to make your radical bigger than 0. And really, the thing that you have to think about is this part right in here. That part right in there has to be bigger than 0, because if that part is bigger than or equal to 0, I can take that. I can take the square root of it, no problem. So what I'm going to do is I'm just going to put what the stuff that's inside called the radicand, and then make that greater than 0. So whatever is inside the radical just has to be greater than 0, and it gives you another inequality to solve. And then you can just solve that inequality so x is greater than or equal to 1. So now you have 2 different inequalities here. And when you think about it, you're saying that x has to be bigger than 1, but also smaller than 17. So x has to, if here's 1 and here's 17, x has to be bigger than 1 and smaller than 17. So x has to be between 1 and 17. So the way that I'm going to write that is 1 is less than or equal to x is less than or equal to 17. This is saying that x is between 1 and 17. All right, so x is between 1 and 17. All right, so let's look at one more. I want you guys to try it, see where you end up. This one's going to be a little bit different because it's kind of a learning process and something you have to think about. I'm going to do a greater than problem instead of a less than problem so you can kind of see how that works. So try this out and see what your thought process is. See what your see what your radicand idea is going to do. Most of you are going to be able to solve this, like the original problem, no issue. But you're going to have kind of get stuck on the radicand thing. Like, why am I doing the radical thing on the inside? So the normal solving process of this shouldn't be too challenging. It shouldn't be something that you guys can't do. It should be something that you are all capable of doing at this point, just for the basic inequality. The radical part might be a little bit more confusing, but we just have to try this out. So I'm going to take the square root of x minus 2 is greater than or equal to 5 because I've divided both sides by 4. So now I'm going to square both sides. So I'm going to end up with x minus 2 is greater than or equal to 25. So now when I solve this, I end up with x is greater than or equal to 27. Right? So I end up with x is greater than or equal to 27. Now, that being said, I have to check my radical, right? So I have to check my radical to make sure that my answer is going to be positive. But you have to think a little bit too here. Right now, I'm telling you that your number has to be bigger than or equal to 27, right? Which means 27, 28, 29, 30. If my number has to be bigger than 27, is there any possible way that my radical will be negative? Not at all, right? So if my number has to be 27 or bigger, the lowest possible number it could be is 27, right? Which means that my radical will be 27 minus 2, which is 25. There is absolutely no issue with this thing being negative because this number is so big. All right? So that's just something to kind of think about. At the end of the problem, think. If I were to plug a really, really big number or a really, really small number or a number into this, is it possible for that thing to be negative? And the answer for this one is no. All right? You can also look at it like this, and let's say you didn't think about that. Let's say you didn't just say, okay, what happens if that number is really big? Think about it like this and say, okay, I need x minus 2 to be bigger than or equal to 0. So then x has to be bigger than or equal to negative 2. If my number is already bigger than 27, is it already bigger than negative 2? Yeah, right? If this number is already bigger than 27, then it's already bigger than negative 2. If I told you, I want you to pick a number that's bigger than negative 2, but also bigger than 27, would there be any reason for me to tell you bigger than negative 2? No, because if I tell you bigger than negative 4, but bigger than 27, it's already bigger than negative 2. So this is the only answer you need. This one is not necessary because it's redundant. There's no reason for you to say I need a number bigger than negative 2 and also bigger than 27. Okay? Does that kind of make sense, the difference between the two? One of them there is an issue with, because if you were to plug in a number smaller than 17, it might make the radical negative. There is no possible way to plug in 27 and make that radical negative. Yeah.
So is it going to be like that for all greater than 5?
I believe so. Actually, I shouldn't say that because the number on the right could be negative. So if this number is negative, there might be a restriction. I think that I would say that like 99% of greater than problems are going to be like this. Okay. Just when you get to your answer, make sure that you question it at least once. Say like, is 27 going to make a radical negative? Is there an issue with that? If the answer is no, then move on. But I would say 99% of the time, greater than problems are going to look like that, and less than problems will look the other way. Other issues or concerns that you guys can think of? Anything else you guys want to see from yesterday that you're a little bit uncomfortable with, or anything you want to talk about before I just let you work on your big idea stuff? We're good? All right.